Okay, let's jump into some more interesting stuff maybe. First off, we have our old program, and I'm going to type in clear, and I just want to do a couple of things real quick. I can do that with ls. I believe that if I type in cls, huh, that doesn't work. Okay, so clear works, but cls doesn't. Okay, these are bash commands in the terminal window, so you can always just do everything you would do with like a Mac computer or a Linux computer. But what I want to do right now is rename this file. I'm going to allow this to happen, and I'm just going to rename this particular file for, I'm going to call it chapter1.cpp. Okay, so there it goes. It's archived now as chapter 1. Last time we used the touch command. This time I'm going to use the code command. So I'm going to say code, and we're going to code chapter 2. For chapter 2, I want to show a couple of things. First off, I want to show how to use coot or console out to display text on the screen. It might help us kind of to understand more about the structure of the C++ program. We include IOStream because we're doing input-output from the console. You don't always use this. It depends on what you're working with. Namespace standard just means we type less stuff. If I don't type in standard, CIN, COUT, all those things don't work natively. There's other namespaces we might use, and there's other libraries we'll include. But this is similar, like in Java, to importing, um, like import IOStream might look like this, or input like Java .io.star would be a similar way of doing that. If we're in Python, it might say, like I'd say using numpy as py, and that brings in a library. This include IOStream is just bringing in the IOStream library, and using namespace standard is the namespace we're going to use. The main method, the main algorithm is under main. From this point forward, I'll be doing headers at the top of the program with my functions called to the bottom. All right, so C++ is not an object-oriented programming language at its core. It is a functional programming language where we make functions, but it does allow us to do object orientation as well, and we're going to show how to make those objects in the program. And it's a little more intuitive than say like Python when it comes to making objects, which makes it a very strong language. And I just want to say, if we're doing comments, this is a single line comment. If you're familiar with Java, this is the same thing. This is a single line comment. And to do a multiple line comment, a block comment, we do this. This is a multi-line comment. Helps if the teacher spells correctly. Comments. It can span as many lines as you want. All right. And of course, because we have this int here, we need to return an int. So I'm just going to say return 0. All right. So, and let's talk about COUT. We're using the namespace standard, so I can call COUT. And to do that, I just put COUT. And this thing, right, this dash dash, tells us to send the string literal out to the console. This command, endl, is very similar to like a print line statement in Java. It just gives us, it just does a return to the next line. Without the inline, you don't see the return. So this is a basic output statement. Right? Basic output statement. If I can ever spell, did I get it right? Yes. Okay. So we can also use variables. Variables store data that can change during program execution, right? If you want to fix a variable, you can use the final, not the final keyword, sorry, wrong language. Use the constant keyword. So let me show you what that looks like. So we have an integer here, age equals 25, and I'm going to have a double pi, and that's going to be equal to 3.14159. Okay. This is now a constant. I'm not going to change pi. It's never changed since circles were found. So we're going to say constant double pi, and I can output this to the console. So I can say like COUT age and I can output pi. And we can see pi coming to the console as well. Alright, that should say end line. Make sure I spelled that right. Oh, I did not spell that right. There you go. End line. There it goes. So now that this shows you variable assignment. So I've declared and assigned those variables for age and for pi. And I guess it's important for us to address what data types are, right? There's a lot of data types that we can use, and I guess I just want to say this, and that's that C has several data types, and I'll just put it here. C++ has several data types, including integers, floating point numbers, characters, and booleans. Each type is used to store different kinds of data, right? And I guess it helps us to kind of see what that looks like, right? So here you can see the double we used here. There's also a character, similar. Again, if you've worked with Java, you can see how that looks, but I'll show it to you here as well. And that is like this: character grade equals A, Boolean passed equals true, right? And so that's a Boolean value, BOL, instead of spelling out Boolean the whole way, right? And I do want to talk about something with the Boolean data type in C++ because it might feel a little non-intuitive, right? And I guess maybe I should output grade 2. You can see what this looks like when I run it. All right, so let's go ahead and save this. You can see chapter 2 is not saved yet. Control S, you can see now it shows up. We're good. All right, so I'm gonna G++ chapter 2.cpp, and we're just gonna call this chapter 2. There you go. All right, and I'm just gonna chapter 2. All right, hello world, age 25, pi 3.159, grade is A. But look at passed. You'll notice passed just says 1. Well, in the world of C++, a true Boolean comes out as 1 and a false Boolean comes out as 0. Make sure you remember that when you're coding, so you can, if you want to make it more intuitive for the user, you can use an if condition to output a string if you want to, right? So what if you want user input? Well, it's actually fairly straightforward in C++ to get user input, and that is using the console in command. So we're going to go ahead and take all of this out, right? And we're going to make an intro method. Intro method. Not what I meant to do. All right, void intro. And I'm going to at the bottom say void intro. We're going to flesh that out. Okay, we're not going to call intro anymore though. What I do want to do is show CIN input, or I'll say console input. And for console input, we'll go ahead and declare that. For console input, we're going to have a program that just shows console input. And versus you watching me script all that, we're going to make it go really fast. All right. There's the console input. So we're going to have the user enter their name and their age, and we're going to do it that way. All right, so I am going to first off save this in case I haven't yet. Save it. Going to compile this, and we're going to run it. All right, so I'm going to enter my name. It's Chad, and of course, I turn 21 every year. So we're going to say that. Hello, Chad. You are 21 years old. So you can see that this console in function brought in the user input from the console and assigned it to that variable where it was used in line 22. All right. What about arithmetic operations? Well, these are fairly straightforward, right? So I'm going to do arithmetic. And we will do this here. Void arithmetic. All right, so I just want to show you with a and a b variable what's happening. Some of these make total sense. Some of these may not, right? But let's go ahead and call the arithmetic function. Arithmetic, we'll call this. I mean, like I said, things are very straightforward. Plus is plus, minus is minus, the star is multiply, forward slash is divide. This is the modulus function, which is also often called remainder, and it's the remainder after integer division. So if we have like 15 divided by 4, we're going to have a remainder of 3 because 15 divided by 4 is 3. 3 times 4 is 12. 15 minus 12 is 3. So modulus gives us that remainder, right? But that kind of begs the question, and something that you'll see on Facebook all the time is these math questions people apparently cannot solve, and that's because they don't have operator precedence. So we need to know about operator precedence, and that's simply the order in which operations are performed, right? So and let me go run this program first, and then we'll talk about order of operations. You can see there's addition, subtraction, multiplication, division, and modulus. 10 mod 3 is 1 because 10 divided by 3 is 3. 3 times 3 is 9. 10 minus 9 is 1. That's how we get that. But operator precedence is very important as well because, for example, I'm just going to go ahead and do one here. I'm going to say, what is the result of 5 plus 2 times 3, right? And I will, this feels like a Facebook question. So if you ask this question on Facebook, 5 out of 10 users, I'm going to say 1 out of every 2 Facebook people will say that the answer is 21. But we know it's not, because you multiply 2 times 3 first because of the order of operations. If you were taught GEMDOS or PEMDOS or BODMOS, then you know that Multiplication and division comes before addition and subtraction. All these are different ways of doing the same thing. So we have multiplication first and then addition. If there is something like this in our program, so 10 divided by 5 plus 2 times 3. In this case, it's not going to really matter which one you do first, but multiply and divide. Divide comes before multiply. We always do it from left to right if they're in the same order. So really the order of operations looks more like a grid than a straight left to right. Multiplication and division are in the same order. Addition and subtraction are in the same order, right? But multiplication happens before addition. Now sometimes you might want to do a data type conversion. We've discussed a little bit about data types. Let's talk about a data type conversion. And it's fairly straightforward. To do a data type conversion, there are implicit data type conversions and there's explicit, and that's called casting, right? So let's go ahead and create a method that we're just going to say type conversion. Let's do it this way, make it simple. We'll say type convert, all right? And we're going to call that type convert. I keep saying method, and that's not true. Function. We're going to call the type convert function here, right? And if you want to know, I usually distinguish between methods and functions because if a object exists, then an object has methods, but outside of an object, and if you call something, it's a function, right? This is a CPP file. It's not a class in the same order as Java, so these are functions and not methods, right? But type convert. And we're going to look at this type convert program. And I guess we should address implicit conversions as well because that might be kind of important. I'll show you real quick how that implicit one works. Okay. Sorry about the yawning. It's been a long day. But these are two integers, 7 and 2, right? And we are returning or we're working a double. So we're trying to convert these to a double. And to do that, we just static cast double x divided by y. Now we have a double divided by an integer, and it's going to return us that double, right? This is explicit type conversion with static cast. And it's manually done. All right. There is also implicit type conversion, and I guess I'll show that to you. If I say double z equals x, right? Well, we'll show that to you right now. If that x is being passed into a double, the x, when it becomes z, is implicitly converted. I can convert things to more complex data types, but I can't do the inverse. I can't go from double to integer because it's a lossy type conversion and it will give me an error. But let's go ahead and run this program and you can see what it does. Let's do this because you can't really see much the way I did it. There it is. So, and in this case, you can't even tell that 7 was cast to a double. But either way, you can see the explicit conversion worked, and we had a 3.5, right? So let's talk about naming constants. When we name constants, it makes them easier to read and identify, right? So it gets rid of some of those magic numbers. So I know there's always 7 days in a week, and I can just use 7. or I can say 7 days in a week equals 7, right? I just want to show you an example of that. It's just fairly straightforward. It's an example of named constants. Basically, please name your constants, because we don't want to see magic numbers. We want to see those things named so it makes sense. All right. So just straightforward. There's 7 days in a week. Sales tax is, we'll say 0.825. So there are 7 days in a week, and the sales tax. This may never change. You may use 0.0825 throughout your program, but if it does change, it can change at one place and the program still works. Days in a week are probably never going to change unless the calendar changes. Either way, this tells the user what you're doing, and it gets rid of those magic numbers. Okay. So there's another data type that is not a primitive data type. It is more complex, and that is a string. And a string is a array of car. You can concatenate and manipulate strings using operators, because that's how the program is made, right? To use strings, we need to bring in another library, and that is the string library, right? And I'm just going to show you quickly concatenation, and I'll do that right here in the main method, right? So we have Jane Doe. We're going to take a full name string. We're going to concatenate Jane with Doe, and they're going to make that the full name. I don't need the return 0 twice. Shoot. I don't need the return 0 twice. Let's do it that way. Okay. And we're no longer calling name constants because we don't need to. Okay. So you can see this string concatenation. There are other methods that we're going to learn about, but this is the basics of what you need to know for strings. You can assign a string and you can concatenate it. Yeah, and that's pretty straightforward. The last thing I want you to know about this chapter 2 is just putting this all together into a simple calculator, right? So I'm going to take out the string here. Well, I hate to lose anything, so okay. So I am going to wrap up with a simple calculator, and this will make sense, I think, straight up because of what we already covered. And the simple calculator, it's going to look like, let me see. We'll walk through the program. So we're going to have the user enter two numbers, and it will find the sum, difference, product, and quotient, which is addition, subtraction, multiplication, and division. And we will just call simple calculator. Right. So let's run this program. I'll say 5 and 10. And you can see 5 and 10. The sum is 15, the difference is -5, the product is 50, and the quotient is 0.5. Okay, so yeah, I think these were pretty straightforward. Hopefully that kind of explains the structural foundations of C++. If you have any questions, let me know, and we will talk to you soon.